In the primary memory, we have RAM and ROM. RAM is what? Random access memory. ROM is read-only memory. Whatever you wanted to execute, whether it is in primary or secondary memory, that should be in the primary memory at the time of execution. Main properties of this magnetism is to what? To store the data on a magnetic surface. What are the magnetic disks we have? That we have is hard disk and floppy disk. Hello everybody, a warm welcome to one and all. Welcome back to the session 4 of chapter 1 in the unit 2 of BCA's first semester, subject called Fundamentals of Computer. I'm Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So before getting into our today's session, we'll just have a quick recap of our previous session. As you all know that in the last session of this chapter, we had a discussion regarding computers' output devices, right? So whenever we wanted to display the resultant after the processing, then we have to go for this output devices. Under that, you studied what is monitor and what do you mean by printer, what are the types of monitor and printer we have, along with a feature that we had a discussion in the last session. And also you got to know that along with the monitor and printer, we have a speaker, plotters, and also we have a projector as an output devices. That is what we had a discussion in the last session. So in our today's session, we're going to learn about the computer's memory. That is what computer memory, in that we have two types. One is primary memory, our main memory, and we have a secondary memory or auxiliary memory. That is what we are learning in our today's session. We'll get into our today's class with respect to this computer memory. So as you all know that computer memory is an essential part, that is very important, and even it is mandatory components of any digital computer that you can take an example. And also mainly it is a storing device. It is going to store the data and instruction which is required in order to do the processing. And even after the processing, whatever the resultant that we are getting, that should also needs to be placed in the computer's memory. And also mainly the storage will going to enables us in order to store the data which we require for future. Then what are the different types of computers memory we have? Here you can see the classification of computer memory. In that we have a primary memory and secondary memory. In the primary memory we have RAM and ROM. RAM is what? Random access memory. ROM is read-only memory. So in the RAM we have a static RAM and dynamic RAM and EDO RAM. Along with that, in the ROM, read-only memory, we have a programmable read-only memory, erasable programmable read-only memory, electrically erasable programmable read-only memory, and also we have a flash memory. Along with that, we can see that in the secondary memory. It's all regarding what? Primary memory, which is main memory of a computer. Next, we have a extended memory, or we can call this secondary memory as a auxiliary memory, that consists of magnetic disk. Under that, we have a hard disk and floppy disk. Next, we have a USB flash, that's your pen drive, SD cards, memory cards, all those are comes under here. And we have a optical media or optical disk. In that, we have a CD, DVD and BD, that is Blu-ray disc read-only memory. So all these are what? The classification of computer memory. First, we'll see with this computer memory, mainly it is of two kinds. One is primary memory, it's also called semiconductor memory. Next, we have a secondary memory, that is also considered as what? Magnetic memory. And also the storage capacity of a computer, we are going to measure in the terms of bytes. How many number of bytes it has. So based on that, we are measuring the storage capacity of any of the computer electronic devices. And also mainly 1 byte in the sense what? That is a collection of 8 individual bits. If it is a collection of 4 bits, then that is nibble. Collection of 8 bits is considered as what? 1 byte. Then how many number of bytes we have? Based on that, we are going to represent the storage capacity of this computer. Fine. And each bit will going to hold either 0 or 1. So if it is 0, that represents off. If it is 1, then that represents on. Okay, or it represents the active or passive state of a electronic device. That's all about computer memory. In that, first we have a primary memory here. As I told earlier, in order to execute anything, Without this memory, we can't do anything. Primary memory is also considered as a main memory of a computer in order to store the programs and to data and which are currently executed by the CPU. Whatever you wanted to execute, whether it is in primary or secondary memory, that should be in the primary memory at the time of execution. For example, you have some content in the CD or DVD, that is secondary storage device, but you wanted to execute that should be copied to the primary memory or a main memory of a computer, then only we can do the execution, so that whatever which is currently needed by the CPU for the purpose of processing, that should be in the computer's main memory or in the primary memory. So here you can see that the size of a main memory is smaller when we are comparing it to the secondary storage devices. At the time, the size of a main memory is smaller. Why? Because it is costlier and also it is going to hold only small amount of data which is required for the processing. And also the CPU communicates directly only with this main memory. That's what the reason I told you that whatever we wanted to execute, everything should be in the main memory. Why? Because CPU can only interact with this main memory. That is what the reason we have to keep the data and instruction which needs to be executed, that should be in the computer's main memory. So and also, as you all know that CPU will going to do the processing at very high speed and we have to match the speed in order to work with that, and we have to provide the storage capacity at the speed of that CPU processing. That can be happen only with the help of this primary memory. Only this primary memory or main memory can provide that matching speed between the processor as well as to the computer's memory. Fine. Then here you can see RAM and ROM both are comes under this primary memory. RAM is random access memory and ROM is read-only memory. So now we'll see about the RAM. If it is RAM, then that comes under primary memory, and if it is what primary memory, that's a main memory, and the speed is very high, cost is also expensive, but storage capacity is limited. RAM is also called the main memory of a computer, and mainly it will going to store, and it's a place where the program gets stored temporarily. So here we are not storing the data and information permanently. Instead of that, we are storing the data and information temporarily at the time of its execution. So when a CPU runs a program, it will going to fetch us the program instruction from the RAM and carries them out. So whenever we are doing a execution, at the time CPU will going to fetch the content which we have in a RAM, then it is going to do the processing. So that's why CPU needs to store the resultant of the calculation. It can store them in a RAM. Even after the processing, before the processing, the content can be stored in this RAM or random access memory. But we have one drawback here, that is what? Volatile in nature. What do you mean by volatile? When we power off the computer, at the time whatever we have stored in a RAM, everything will going to get erased or vanished. Then we are calling that feature as what? Volatile nature. So if the content or a instruction get erased or get vanished after the power switch off or when the power supply is off, then we are calling that form of memory as what? Volatile memory. And what are the types of RAM we have? We have a static RAM and dynamic RAM. That's all regarding what? RAM. Next we'll see about the ROM or read-only memory. As the name indicates, here we can write it once, but we can read it many times. Once the content is fed to this ROM, that can't be changed in a future. Fine. Then that is considered as what? Read-only memory. The information is pre-recorded into the ROM chip at manufacturing time. So operating system, all those kind of application or a software that will going to be copied or that will going to be stored in this ROM. Why? Because that doesn't need to be changed often. Then at the time we can store that kind of information in the pre-recorded form with the help of this ROM chip. Once the data has been written onto a ROM chip, it cannot be erased, but you can read it as many times you wanted to read. When we switch off the power or a computer, when the power supply is off, but whatever the content we have in a ROM will not at all get erased. Then we are calling this ROM as what? Non-volatile memory, and it is going to store the data and information permanently. That is the difference between RAM and ROM. Though it's in a primary memory, it is non-volatile in nature. And also this ROM is used in order to store the critical information which is very highly confidential, which the program that is going to boot the computer, that means which is loading the operating system to the computer's memory, will going to be done with the help of this ROM. Then we are calling that critical part of a computer will going to be stored in this ROM memory or read-only memory. Fine. Next, what we have here, it's all regarding types of ROM. So we have a programmable read-only memory, EPROM, that is erasable programmable read-only memory. Then we have a EEPROM, that is electrically erasable programmable read-only memory, and we have a flash memory. All these are the types which comes under ROM. Here you can see the difference between RAM and ROM. What is the first difference? The RAM stands for random access memory and ROM stands for read-only memory. Fine. Whatever we have in a RAM, that is volatile in nature. That means the content will going to get erased or lost when the power is turned off. But that is not in the case of ROM. Why? Because it is non-volatile in nature. And this RAM allows the computer to read the data quickly in order to run the application, and also it performing reading and writing operations. So we can read the content and also I can give the content to the computer's memory, that is RAM. We can do the operation read and write. Both can take place in the RAM. And what about ROM? This, as the name indicates, read only. Once we can write, but we can read as many times you require. So it allows only reading. It stores the program which is required initially to boot the computer. Booting in the sense what? Loading of operating system to the computer memory is called booting. That is going to be done by this ROM or a read-only memory. Then what are the example for this ROM, or what are the types we have in a RAM? That include static RAM and dynamic RAM, that is SRAM and DRAM. Then what are the types of ROM? We have a PROM, EPROM and EEPROM along with a flash memory. It's all regarding what? Primary memory along with RAM and ROM, its types and feature along with a difference. Next, we'll see about this secondary memory. So as you all know that now in the primary memory or in the main memory, we have only smaller size of memory space or a limited size of memory is there in the RAM and ROM. So what if I wanted to store massive data? What if I wanted to store large amount of data? Then we have to extend the storage space, that too by making use of this secondary storage devices. Once we got to know that when the primary memory is not so very large in order to hold large amount of data, then we have to require or we need some more space or a memory location in order to do the processing. That's why we have this secondary storage spaces required, and also it is considered or used as what? Auxiliary memory, which is extended memory of a computer is called auxiliary memory or a secondary storage devices or a memory. And mainly it is used in order to store bulk storage of data or mass storage of programs, data and other information which can be stored in this secondary memory. It has a larger capacity and it is going to be slow. When we compare this with the secondary memory to the primary memory, somehow secondary memory is low, but it is affordable in nature. That means cost is not so high than the primary memory. And also the secondary memory retains the information once stored on it until we are going to delete it. You can take the example of your SD card, pen drive, hard disk and all. Until we are going to delete it, it won't get erased on its own. That is what it's non-volatile in nature. The content or information whatever we have in a secondary storage space will remain until we are going to delete that. And what are the examples which comes under this secondary memory? So there we have a magnetic memory, optical memory and static memory, or we can say that as what? A solid state memory. In the magnetic memory we have a hard disk, floppy disk, and in the optical media or optical memory we have a compact disk, CD, DVD, and in the solid state memory there we have a pen drive, memory cards. All these are most commonly used secondary storage devices or a secondary memory. And also Here you need to understand what is access time. So based on this access time, we can get to know the speed of a computer. Then what it represents? The average time required to reach a storage location and to obtain its content, then we are calling that as a access time. When we have more access time, that means the speed is slow. When we have a less access time, at that time we are getting the resultant in a very fast manner. So access time should be less. If it is in 2 seconds, 3 seconds, nanosecond, then the processing speed is very high. We are fetching the data and information on the storage space very quickly. But if the access time is high, then the speed of that processing is low or the speed is less. Next, we'll see this magnetic disk or magnetic media, which comes under the secondary storage devices. So here mainly it is of thin circular plastic plates on which some magnetic material is coated. So here all these secondary storage medias are what? We have a different methodology in order to store the data. So here we are using magnetic material which is coated on a thin circular plastic plates. On that we have this magnetic media. That magnetic media is holding the data and information permanently, and then it comes in various sizes and materials, and also main properties of this magnetism is to what? To store the data on a magnetic surface. Then we are fetching the data from that magnetic surface, and a disk pack normally consists of such disks mounted on a central shaft. So it is looking like this. Central shaft will be there. On that we have a circular plastic plates. That place is holding the magnetic disk on it. On that magnetic disk, it has the ability to store the data and information permanently. Then what if it is doing the rotation? You take the example of floppy disk, hard disk and all. So when we insert that, it will start rotating. Then the central shaft rotates at speed about 7,200 RPM, that is revolution per minute. When the RPM is more, at that time the speed will going to be very high. Then we can fetch the data and information, that is read or write operation can take place in a very fast manner. So that up to 7,200 RPM, this magnetic disk shaft will going to rotate. Then in a disk plate, information is stored on both the surface. If you consider the hard disk, floppy disk and all, it is going to store the data and information on both the surfaces, and the surface is further divided into number of invisible concentric circle. Then we are calling that as what? Tracks. So if it is thin circular plastic plate like this, then it has the ability to store the data on both the surfaces. Then we are going to divide this into number of concentric circles. So if we consider like this, then it will going to have a number of concentric circles, and we are calling this as what? Tracks. And the tracks are further divided into another various section, then we are calling that as a sectors. So for example, if it is a thin circular plates, then it is divided into number of tracks, and again the tracks are divided into number of sectors. And if I wanted to access the content, I should know in which sector, in which track the data is stored. Okay. So this is what thin circular plate. In this we are calling this circular circles as what? Tracks, and the tracks are again divided into number of sectors, and in order to store the information, you have to identify or you have to know what is the track and sector where the data has been stored. After that, the stored information can be read any number of times without affecting the stored data. So you can watch the movies any number of time. So that is what will going to be stored in the hard disk. But when the new data is written, it will going to erase the previously written data. That is one of the drawback. And what are the magnetic disk we have? That we have is hard disk and floppy disk. In order to access the content of hard disk, we require HDD, hard disk drive. In order to access the content of floppy disk, we require floppy disk drive. So these are the two examples of this magnetic media or magnetic disk. Next, we have a optical disc. In the magnetic disc, we have a magnetic coated material that is going to hold the data. In the optical disc, here it's a storage media that hold the content in the digital form. So here it is going to hold the content in the digital form. So here we are going to use, or we have this optical media in order to store large amount of data. We'll see some of the point. It uses a laser in order to read and write data. There we have a magnetism, but here we have a laser that is going to help us in order to read and write the content to this optical media or optical disc. So here you can see that in optical storage media, the data will going to be stored in the form of that are prepared by using a laser beam. So how the data is going to be stored? By making use of this laser beam, and we are calling that process as what? Burning of data onto a disk. You might have heard what CD burning, DVD burning and all. That means what? We are storing the data to that optical disk or optical media, and then the data on the storage medium is read by bouncing the laser beam off the surface of that medium. So if you consider this as a medium, then they are penetrating the laser beam, then it is going to bounce to that particular surface of a optical medium. Then if the beam hits a dot, so if it is reaching on the surface, at the time it is reflected back. So at the time we are calling that as a 1. Okay, that is going to represent as a 1, and otherwise records are put as a 0. If it is reaching that medium, at that time it has the ability to write the content. If it is bouncing back without touching that surface medium, then that represent as a 0. And then optical disk capacity ranges up to 8 GB. And also this tends to be slower if you are comparing this optical media like CD, DVD to the hard disk. It tends to be slower of any of the hard disk drives. And what are the examples which comes under this optical disk or optical media? We have a CDs, compact disc, DVD, digital versatile disk. So these are the example of this optical disk. So here in the optical media or in the magnetic media, we have a rotating part. But what if we don't have any rotational parts or a moving parts? Then that is considered as what? Solid state storage. So mainly this is what? No moving parts we have. If you consider the SD cards or what pen drives, that is not at all moving. Right? So solid state storage devices are based on the electronic circuits with no moving parts. Mainly it is of what? It is made up of electronic circuits where we don't have any of the moving parts. That's why it's called it as what? Solid state storage media, and it's going to store the persistent data on the flash memory. And also this mainly have a high performance storage devices, and even cost is not so high. It is affordable, and also it is not so fast. Why? Because it is having a more storage capacity. The time it is going to take for accessing will be somehow more. That's why it's not so fast. Then what are the example we have for this solid state storage? That include pen drives, memory cards, SD cards. So all those are the examples which comes under this solid state storage. So it's all regarding what? Primary and secondary memory. So we'll brief it out with the difference between those two. So in the primary memory, it's considered as a semiconductor memory, but main memory is what? Magnetic or optical memory. And then it is volatile in nature. It is going to store the data and information temporarily, but it is non-volatile in nature. And it is very expensive. Primary RAM and ROM is very expensive. But if you consider the secondary storage space, it is less expensive than the primary. Then it is faster while executing. The processing will be faster in the primary memory. Somehow it is slower. Why? Because it is tends to store large amount of data. So it is somehow slower than this primary memory. And also we are calling it as a main memory, and we are calling this as a auxiliary memory. Then what are the example? RAM and ROM. For this secondary storage memory, we have a hard disk, pen drive, and SD cards, CD, all those are the example of this secondary memory. So together we can brief it out it as a computer memory. I hope you all understood my today's session. In my coming session, we're going to see about the operating system, in short that is OS. Let me meet you there. Until that, keep learning, keep on growing. Thank you.